Guys, welcome back to Quiz TV. Hey guys, welcome back to Quiz TV. So let's focus on linear momentum. We are seeing what physics, JAMB Physics Class you get. So we have to look at what were the three Newton's laws of motion. I want to state them for you because there are things JAMB normally ask in the exam. First, Newton first law of motion, Newton second law of motion, what Newton third law of what motion. I want to explain to you. They want to look at what's called momentum, what's called force, and what's called what impulse. After that, we have to look at what simple calculation, how you can use this formula we have to derive to solve problems. So when you have faced question in your JAMB examination, how do you tackle what this question? So these are things you have to look at in this class. So make sure you stick to the end of this video and take down every single thing. So let's look at what Newton's laws of motion. Newton's law of motion. I get, and there are what three laws of motion. I get. So the first one is what law of inertia. The law of what inertia. So we are called the first law. The first law of motion is called what? Law of what of inertia, which I want to explain to you as move on. Number two, law of what acceleration. Law of what of acceleration, which called second law of what motion, second law of motion. Then number three, law of what interaction. So now let's say first one here. What is Newton's first law of motion, which is called law of inertia? Newton's first law of motion states that a body will remain at rest or move uniformly in a straight line unless acted by an external force. You understand? So the concept inertia means that the tendency of a body to remain at rest, to be at rest. Do you understand? Or the tendency of a body to be moving, to move continuously. That's called the word inertia. Because when a body is at rest, it wants to be at rest unless something is act on it. When a body is moving uniformly, it wants to continue moving uniformly unless acted by external force. This is where Newton's first law came from. That's why it's called the law of what inertia. So let's look at what the law of acceleration, which is called the second law of motion. Newton's second law of motion states that the rate of change of momentum is directly proportional to the applied force and move in direction of what of that force. I want to explain this to you because this second law is very important. This is what we are going to use to derive what we call the force what an impulse. Now look at what law of what interaction. Now the law of this is third law of motion states that action and reaction are equal and what and opposite. What does it mean? It means that for every action there's always equal and opposite reaction. Just as so these are what the three laws of what of motion you need to understand here. So next I want to look at is what is momentum, force and what an impulse. Okay. So let's look at what momentum first. What do you understand by momentum? What is momentum? Take down. Momentum is product of mass and its velocity. So product of mass and what and velocity. Okay, so whenever I talk about momentum, is what mass times what velocity. Just that. So that is momentum. There is momentum equals to what mass times what the velocity. Okay, mass times what velocity. Now mass is what is m, velocity is what is v. Do you understand? So that momentum is what m what v. Now what is the unit? Remember the unit of mass is what is kg when it comes to what physics. Now the unit of what velocity is what meter per second. Again, so that the unit of momentum is what kg meter per what seconds. Correct. Again, so look at something here. If a body is at rest here, kg. Now let me say a body is at rest. Now remember when the body is at rest, the Initial velocity is what is zero, right? It has what initial velocity of zero. Now, when a force is being applied, what will happen here? The ball will move from point A to point B. So let me just say it moved here. Now let me ask you here, when a body move from here to here, does the mass of the body change? The mass of the body remain the same. Right there. So going to be what kg here. Right there. So the mass of point of ball A, now here is called ball A here. You understand? So when at here, it move from here to this other point here, right? What happened here? The mass remain the same because it's the same ball here. But what happened to the velocity? Now here we have the initial velocity because at here it's always zero. Now when you now apply a force, what happen here? It now change what velocity. So you have now add what v. Do you understand? So it means that let me write in the body. There's always what change what position, which change what momentum. So you can now say change in momentum. Change what in momentum. Change momentum. Change momentum equals to what? Final momentum. Final what? Momentum. Minus what? Initial what? Momentum. Is it okay? Change momentum equals to what? Final momentum minus what? Initial what? Momentum. Now remember, final momentum, we go to our what? Final what? Velocity. Initial momentum, go to our what? Initial what? Velocity. Initial what? Velocity. The mass remains the same. So if you look at final momentum, remember, momentum equals to mass times what? Velocity, right? So that would be the mass times what? The final what? Velocity. Do you understand? We're going to be what? M what? V, right? So when we look at our initial momentum, initial momentum equals to what? Mass times what? Initial what? Velocity equals to what? M what? U, right? So my change in momentum, is equals to what? Final, which what? mv minus what? Initial what? M what? U. Right there. So since m and m are the same, I can what? Figure out m out. So going to be what? M v minus what? U. Can you see that? As easy as that. That is it. So this is what my change what momentum. So the next one to look at is what? Let's look at what the second law now, which is called the law of acceleration. So if you look at the law of acceleration, if you look at what laws of acceleration here, if you look at it very well, see that the rate of change of momentum is directly proportional to the applied force and acts in direction of that force. That means force is directly proportional to the rate of change of what? Momentum. Please take it down. Right there. Then the force is always directly proportional to the rate of change of what? Momentum. It means that the higher what the force, the higher what the rate of change of what? Of momentum. Just that is the higher the force, the more it's what? The higher what the momentum. Right there. Now we're talking about rates. Rate always deals with what? With change in time. Right there. Like it's changing in respect to what? To time. So remember, momentum is what? Momentum is what? Momentum is what? Mass times velocity, right? So when we talk about rate of change of momentum here. So when you look at what? Rates of change of what? Momentum. Right there. Because the time about it, I go to change in respect to what? Time. So I'm going to do what? Change of what? Momentum. Change of momentum over what? The time it takes. Do you understand? All about what? Time. Do you understand? So whenever you talk about rate of change of momentum, you're actually talking about change of momentum over what? Time. This is called the rate of change of what? Momentum. Time is always included. Right there. So when you talk about rate of chemical reaction, right there, rate of chemical reaction is equal to concentration of time. That is the rate at which the concentration is what it's changing over a period of time. So now whenever I see rates, we talk about it changing that quantity is changing in respect to time. So when we talk about rate of change of momentum, we are talking about what the rate at which the change of momentum in respect to what time. So when the what change of momentum over time. What does it mean? It means that force is what is equal to what is directly proportional to what change in what change in momentum. You can just say change in momentum. Change in, here is not in. Change in what in momentum. Change in what in momentum over what the time. Right there. Now remember, my change of momentum is all this one here, right? Look at change of momentum here. So here you can see that F is equals to what N V minus U over what T. Can you see that? M V minus U over what of T. So this is not the expression here. Now remember, here is what inversely here. But if you should remove it, we assume that the constant is what is 1. So it is sent out as W. Right there. So it is sent out as equal to. Can you see that? So this is now what for the what first for the second law of what motion. The rate of change of momentum is directly proportional to what to the applied what force. So that is force is directly proportional to what to the what change the rate of change of momentum. So that's what you now see here. So look at something here. Let me break it down for you. If I should separate it here, I would have F is equal to M times V minus U over what T. Right there. Now remember, velocity over time or change of velocity over what change in time is also known as acceleration. Do you understand? So A is equal to what velocity or change of velocity over what change of time is okay. It means that my A is going to be what V minus U over what T. That is meaning. Just now, final velocity minus initial velocity over what the time it takes. Do you understand? So if I should apply that here, that would be F is equal to M times what A. This is where the formula for force comes in. Now, so you derive formula for force from the second law of what motion, we call it what the law of what acceleration, which is what the law of what of acceleration. Do you understand? So this one is key here. So we have looked at what momentum, we have looked at what force. Let's look at what impulse. What do you understand by impulse? Impulse is defined as the product of force and time during which it acts on the what objects. Again, so when we talk about impulse because of what force times time. Again, force times what time. Force times what time. Now, and it's also equal to what change in what in momentum. And it's also what change. So yeah, consider impulse equals to what force times time. Also it's saying what change what in momentum. Change what in momentum. Right there. So remember, from the Newton's second law of motion, we have derived something like the F equals to what M V minus U over what T, right? What up here? If you should cross multiply, what up here? You're going to have what F T, right? Equals to M V minus what U. Right there. So and this that impulse is what is the product of force and its what time doing what when it acts on the what object that is called the impulse. So here you can now say impulse here. Impulse is equal to what F T equals to what meter mass final velocity minus initial what velocity. So if you look at it very well, but our point of focus is going to be this one here. So you can now say impulse equals to what? Ft. Remember, F equals to what? What? A, which called what? Mass times what? Acceleration. Right there. So here you can impulse equals to what? Mass times what? Acceleration times what? The time. Is okay. Now, what is unit of mass? Mass is what measured in kg. The unit of mass. Mass is what is kg. Now, what is the unit of acceleration? Meter per second square. Meter per second square. Now, what is unit of time? Time is what? Is what? Seconds, right? So if you should break it down here, I would have kg meter per seconds. Now, the condition is 1. Just down. So now we have s minus 2 times x1. In this is here, going to be what? X minus 2 plus 1 going to be what? Minus 1. S what? Minus 1. I don't want to go into that now. So the unit of impulse, the unit of impulse is what? Mass times mg meter per what? Okay, now let's look at some basic question here. So we have the first 3 questions. I want to go to also about 6 questions. So we have the first 3 questions. So it's just for me to be able to explain to you, to know how to use the formula to what? Solve problem. Now, for you to solve any problem in physics, first of all, you must understand the question. From the questions you are being asked, that is where you have to what? The parameters be given to that way you are going to get the formula to use. There a net force of magnitude of 0.6. So that is my force is what? 0.6 what? Newton, right? Acts on a body of mass. So my mass is what? Is 40 grams. Initially at rest, calculate the magnitude of the acceleration. So here we have A is okay. It's very easy. We are using what? F equals what? M what? A. As easy as that. F equals what? Ma. So making A the solid formula here, if you make, because you are looking for acceleration here, it's going to be A equals what? Force over what? The mass. So going to be A equals what? My force is what? 0.6. But guess what? You have to convert this one to what? To kg. If you should use one like this over what? Probably Newton over what? 40 gram. You have to fill it. Do you understand why? Because this gram must be converted to what? To kg. And to convert 1 gram to kg, you have to divide by what? 1000. Do you understand? Because if you like, I want to fill it. Get, because in the unit of mass that we use in physics is what? Is kg. But in chemistry is what? Is gram. You get. So since we are talking about physics here, I want to convert what? Gram to what? To kg by divided by what? 1000. So if you convert to 1000, you're going to do what? Now if you convert to what? Okay, you're going to be 0.04 kg. Do you understand? So this is what I'm going to use here. So it's going to be 0.04 what? Kg. Do you get? So what will that be answer? 0.6 divided by 0.04. So you have 0.6 divided by 0.04. Here we have 15. 15. Now, what is unit of acceleration? Meter per second what? Square. Right there. That is unit of acceleration. Easy. Right? So that was the first one. So look at the second question. So look at a second question here. There's a truck of mass 3,500 kg moving with a velocity of 15 meters per second, increasing its velocity to what? 27 meters per second in 6 seconds. Calculate the magnitude of the force exerted on the engine. So that is my mass. What is my mass? My mass is what? Is 3,500 what? Kg, right? Moving with what? With a velocity of, is moving what? With a velocity. So it's already moving. So this is what is going to be what? My initial velocity. Is moving with a velocity of what? 15 meters per second. Increases its velocity to what? 27 meters per second. So here we have the initial velocity is going to be what? 15 meters per second, right? Then my final velocity V is what? Is 27 meter per second. Just now my time, what going to be my time? My t is going to be what? My time is what? 6 what seconds. Now what they say calculate the magnitude of the force. So F, what do you look for? So which one are we going to use? Remember, force equals what? M what? A, right? A is what? V minus U over what? T, right? So we have F equals to what? M V minus U over T, right? So if you also say that what F equals to what? M V minus U over what? T. Now we know the mass, right? We know what my final velocity, we know what my initial velocity, I know what my time. Just want to substitute your values there. So F equals to, my mass is what? 3,500. My final velocity is what? 27 minus initial velocity is what? Is 15 over what? 6. So this minus this time is divided by this one here. You get your answer as easy as that. So here we have 27 minus 15 times 3,500 divided by what? 6. Here we have 7,000 what? Newton. That is it. 7,000 what? Newton. As easy as that. Just if you are following this class here, please leave a comment section that you are following this class. And if this video is helpful, please only leave it at the comment section that this video is helpful. Please, you are trying to get to 5,000 subscribers as soon as possible. So you can kindly be part of the class here. You can kindly be part of the growth of this channel to get to 1,000 to 5,000 subscribers. The only thing you need to do here is just like and comment. And if you have not subscribed, kindly subscribe. So these are the only things you need to do here. They can go further by sharing this video to other persons like you who are looking for this kind of content. Do you understand? So this is the only thing I want you to do for me as a reward of me taking you for free. Do you understand? So kindly leave at the comment section that this video is helpful. You get and like this video. And if you're not subscribed, please kindly subscribe to this channel. It helps to tell YouTube algorithm that this video is helpful. More people need to see this. These are YouTube promote videos in their platform. Do you understand? So I really appreciate that. I really appreciate if you can do that for me. Subscribe now. Leave your comment at the comment section. Then like this video. Then copy this link and share to other other JAMB group. You get that they know that they need this video here, right? Okay, I believe we have done that. Let's continue here. How do you solve question 3? They say a moving car of mass M is equals to what? 650 kg, right? Express a frictional force. Frictional force is what? Is 200 what? Newton, right? If it accelerates at what? 3 meter per second square. So you're going to be meters. So you're going to be A equals to what? 3 meter per what? Second what? Square, right? Calculate the magnitude of the force applied. So magnitude of the force applied. Remember, this one is frictional force. Remember, frictional force is an opposing force, right? Do you understand? So they say we should calculate the magnitude of the force applied. So what force do you apply in order to what? To resist or to move it? Do you understand? So now that is applied force. Now applied force. That's what you're looking for. Is okay. Applied force. So applied force. So now how do you calculate applied force? Applied force is always equal to what? The net force right there times or plus the frictional what? Force. This is what you need to. This is what you need here. So then the applied force is what? Is net force you add inside, and what? The frictional force, the opposing what? Force. Do you understand? So that is called the frictional what? Force. So how do I get my net force? My net force is just like the force I applied. Remember, force goes to what? Mass times what? Acceleration, right? What is my mass? My mass is what? 650 times my acceleration is 3. So what happened here? 350 times 3. 650 times 3. Here we have 1950 what Newton. So this is now what my net force. So net force equals to what? 1950 what Newton. Right there. Now when they say you calculate applied force, so applied force now, applied force is equals to what? The net force which I've calculated here, 1950 plus by frictional force what? 200, right? So 1950 plus 200 equals to what? 2150 Newton. That is the what answer. Okay, now let's look at what the last two set of questions in this video here. They say that a rope is being used to pull a mass of 10 kg vertically upward. Determine the tension in the rope if starting from rest. The mass acquire a velocity of 4 meters per second in 8 seconds. Now they give you it here. So the first thing we want to look at, what is tension? Tension is the difference between the weight of the object minus the force, the upward force. Just like this is what you need to understand here. Yeah, if you look at it very well, you see that the rope is being used to pull a mass. So mass is what? 10 kg, right? Determine the tension if the rope starts from where. So my velocity here, the velocity I used to pull the rope is what? Is 4 meters per second. Remember, they say that what? It starts from rest, right? It starts from rest. So the body starts from rest. So that is my initial velocity is going to be 0, just because it starts from rest. Now the time it takes, the time is what? Is 8 what? Seconds. So now you need to pay attention to all the statements here, because do what you are going to use what somebody put here. Determine the tension in the rope if started from rest. Now it starts from rest, that is the initial velocity is what? 0. Why the mass acquire a velocity? So my final velocity is what? 4 meters per second square. The time is what? 4 meters per second. My time is what? 8 seconds here. So how do we calculate the force? Because first of all, you need to calculate force. Now force equals to what? mv minus u over what? C. Now if I ask here, why are we going to use this formula here? The reason why I'm going to use this formula here, because I know my mass, I know my final velocity, my initial velocity is 0, my time is what? 8. So afterwards, for here I can easily calculate what my force. So we're going to be what? 10 times, you're going to be 4 minus 0 over what? T. 4 minus 0 is what? Is 4 times 10. So you have 8. So we're going to be what? 40 over what? 8. So if you divide it here, 40 divided by 8, here we have 5. So my force is what? Is 5 what? Newton. Now how do I get my weights? Remember, weight is what? Is the mass being acted by the gravitational pull, right? So that my weight goes to what? Mass times the gravitational what? Force. Right there. Weight equals to mass times what? The gravitational force. Gravitational force is what? 10 meters per second. So what my mass? My mass is what? Is 10. 10 times my gravitational pull is what? Is 10. So going to be 10. We're going to be what? 100 Newton. Right there. So for you now, can you get what my tension? My tension in the rope is what? Is 100 minus what? Minus 5. What will be the answer? 95 what? Newton. So the tension in the rope is what? Is 95 what? Newton. You can see how easy it is, right? So let's look at the last question before we end this class. You see that a ball of mass 5 kg hits a smoked vertical walls normally with speed of 3 meters per second and rebounds with the same speed. Determine the impulse experienced by the wall. So it's just determine what the impulse. Now when you talk about impulse, remember impulse. Remember when you talk about impulse, what do you understand by impulse? Impulse equals to force times the time equals to what? Mass v minus what? U. Right there. So we cannot use one here. We are going to use this guy. You understand? So impulse here, impulse equals to what? M v minus what? U. Can you see that? So my m is already what? What is my m? My m is what? 5.0 kg, right? It's a smooth vertical wall normally with a speed. So there is my initial velocity here is what? Is 3 meter per second, right? And reverse with, so my final going to be what? Minus 3 meter per second. Now why is it going to be minus here? You have to say because it's coming back negative, you understand? So it's coming back. So they have the same magnitude, but here is what? Minus here. So from there I can really calculate what's your impulse. So when you input the value here, impulse equals to what? My m is what? Is 5 times. Remember my final here, we have final here, which was minus 3, right? Then remember here is what? Minus. Remember here is minus here, then 3. It's okay. So we're going to be 5 times minus 3 is what? Minus 3 is what? Is minus 6. So we're going to be what? 5 times minus 6 is okay. So we're going to be 5 times 6 is going to be what? 30. Now what is the, now there's impulse here. Impulse will go to minus what? 30, right? But you remove the minus, so you don't always include the minus, so the minus will go out. So don't always include minus, so the minus will go out. So 30. What is unit? What is unit of what? Mass is what? Unit of mass is what? Is kg. Now what is unit of what? Velocity? Meter per seconds. So that is what is the answer. So you don't include what? The minus sign. Do you understand? So that will be the end of today's class. Hope you enjoy this class. Please leave at the comment section that you follow the class. If you have any question, always leave at the comment section. Now, which part of physics is also giving you headache? Please leave at the comment section so I can hear from you. It's through the comment section that is when I will know the next video to produce. You get. And if this video is helpful and you understood everything you have done, kindly share this video. Kindly share this video to your friends. You understand? The other topic in what? Mass, chemistry, and physics that can also interest you, check the screen below or you see some at the end screen. You can go check it out. Thanks for watching. See you in the next video.